Okay, finally we can come to simulate this. So ABD bullet solver. I'm just going to do this with this solver because we don't need to build our own DOP simulation. You know, we don't need to do anything in there, so this just saves a lot of time basically. So bullet solver, visualize that. We don't need to do much in here, to be honest. I'm gonna generally just gonna give it some more constraint iterations, especially since we're using soft constraints. Okay, it's kind of important. Gonna drop a ground plane, but just drop it down really low. I just don't like the idea of the pieces kind of falling. You know, we're not gonna actually see them from our camera angle, but just to have something for them to collide on. We could use that as well, you know, when you see the pieces fall and land on there for problem solving if anything weird is happening with the animation. Okay, forces, I'm going to lower the gravity substantially. Okay, that will help to give us a sense of scale. So this, you know, it's a bridge, but if you think about the scale up until now, this is 15 meters there, so 30 meters across. It's nowhere near big enough, so dropping the gravity will mean that things fall slower and will seem bigger. All right, let's see what else in the advanced tab. This bullet world scale, this is very helpful for something like what we've got here. We've got some big pieces. Let me just turn on the wireframe for this pack geometry. So if you press D to go into your display options, go into geometry and take wire over packed geometry. Okay, just so we can see the pieces a bit better. So we've got some really small pieces on a big object here, and that can be problematic with bullets. And whenever you've got small pieces, and maybe if you see them kind of behaving weird, like vibrating or spinning, or they don't stop, or they're doing weird movements, this can be very helpful. This world scale is to do with the actual size of your simulation, right, of your pieces. So out here you won't see any difference. If I just set this to 2 and then double click and go inside, we should see, can see the scale changes. It's gone much bigger now. Okay, so that's showing that what we're doing is actually we're literally making it bigger. Okay, in terms of the simulations, because now you can see, if we see if you look at the top here, you can see we're actually inside the DOP network now. And it's been scaled up, and we come back out here, and it's kind of made bigger to go into the simulation and brought back down smaller again. So we don't see any of the effect of it here, but we'll get a better simulation. So I'm just going to push this up to the top values, which is 1000. So it's made way bigger, and should give us a cleaner simulation. So that's pretty much it. You know, that's all we need to do here to set up our simulation. I'm going to, maybe we can visualize, no, you can visualize the active attributes, but we've seen that that's working. You can see it's black, and then I think they turn green when they become active, but I'm just going to turn that off because it's just kind of difficult to see. So I'm going to flipbook this just like this. I want to see how it goes for the first few frames. I probably won't do the whole thing. I want to see the metal bending and some pieces falling, and make sure the animation is working as well. Okay, so I'm just going to line up my camera like this. Let's save it first and flipbook from here. Right, I've just got 80 frames there. So watching this, some good and some bad. Obviously we can see, you know, the animation is coming through fine, and the you know, we can see the pieces are becoming active and then falling, starting to fall away from the rest of the bridge. Bad things are none of the constraints are breaking. Okay, we need to set up the braking. Also, I'd like to add a bit more, allow the metal to bend a bit more. Okay, so let's come out here. I'm going to go back up to all the way here to these metal constraints, right? And I'm going to bring down the angular stiffness even more for these metal constraints, so that allows them to bend really easily. and the threshold, I'm going to push this up to 10. So that means the plasticity won't happen until they're allowed to bend up until 10 degrees, I believe that is, and then in degrees. So after 10 degrees, it will start to hold this new shape. Okay, so that means it'll bend easily, because I saw that I felt like they weren't bending enough. So come back down here. That might have to run through the we'll have to run through the convex decomposition again. No, it seems okay. I was worried I'd have to do this again. No, that's fine. Great. And then let's set up the breaking of those constraints. Okay, so come into constraints, breaking thresholds. Okay, and we want this to only work on those connectors. So set this to connectors. Okay, not on those. We don't want it to be breaking the metal constraints. So specifically select the connectors there. And then set this, I'm going to set this to 0.02, pretty low value. So when the constraints are stretched, the rest length is increased by 0.02 or more than 0.02, they will be deleted. Okay, and you can do this by force, which is quite good as well. The angle, if they bend too much, then break them. Lots of different things. But distance is a pretty safe way to do this, right? So that should be good to go. I'm going to drop a RBDIO. Simulation didn't take too long, especially at the beginning while most of it is not active. Okay, I'm just going to connect up the geometry coming out here, and then the points, the simulation points, set this to geometry and points. Okay, so if we just take a look there, what we get is just the points coming out here. And these will be animated, but this will be very, very light on our memory. Okay, it's very easy to save these points. One thing I just realized, what I want to do is save that active attributes. Okay, I'll explain why that is in a moment. If we come back into the bullet solver here, come into advanced, output, and then transfer attributes. We want to transfer that active attribute, so then I will get, you can see the color changing there because we're still visualizing the active attribute, so we'll get that on our points, and then we want to make sure that we get that in our saved geometry as well. So in this save filter, come here and go, you can see there it's going to be deleting everything on the points except for these attributes, so we need to say except for active as well, because I want to keep that active value, and you'll see why when we, once this is done. Okay, so we're keeping that active attribute, we're saving the geometry and the points, so the geometry will be a sequence, and then the rest geometry will be this, which won't be animatable. We'll just have one frame, and then we'll use those points to animate this, so which is much more efficient. So let's save that. We'll save that in our geo folder. That's great. We'll call this bridge. Maybe we'll put it in its own folder. Bridge, not question mark. Bridge like that. Let's put bridge sim, because that's what it is. Okay, control, copy that. Bridge sim rest is fine. I don't want $OS. Let's call it just bridge rest. Bridge.rest.bgeo, and then here make sure you have a /. So we'll make a new folder and then call this bridge.sim. Get rid of that $OS. And then we got $F. We got 3. We need a frame padding of 3. Okay, because we got 250 frames, and $SC is fine. I think from what I understand, $SC is just a bit of a smaller file size, but it can take a bit longer to load in. So I think the file size is going to be small, so I'm going to get rid of that and get rid of it here. Okay, make sure you don't have $F3 there, okay, because we just want the one frame. So we save that one frame, and then when we save this, it will save those 125 frames. Okay.